Hey everyone, so this is tricky. I read this question incorrectly before, so I read it correctly now. So here's my lighthouse, and it is 200 meters from the shore. And then there is a beam of light that is rotating around it. And that beam of light, the d theta dt is 2 pi radians every 9 seconds. So that is that rate. And it wants to know how fast it's moving along the shoreline, that beam of light. In other words, that's kind of that beam of light right there. How fast is it moving across the shoreline when it is 1,400 meters from the lighthouse? So I originally had 1,400 meters on the leg of this right triangle. So this is actually, that is 1,400 squared minus 200 squared, and that is my x, and I'm going to want to find dx dt, so not a big deal. So here's what I know. I know that the tangent of that angle is equal to x over y, or I might write it like this: y times tangent of theta equals x. I'm going to implicitly differentiate this, and so that is a dy dt tangent of theta plus y times secant squared of theta, and d theta dt, and that equals dx dt. Now, dy dt, the y doesn't change. The 200 does not change, so that term goes to 0. And I know what y is. Y is this, y is 200. And then I know what secant squared is. Theta is the arctan of that big square root up there at the top over 200. So if I plug that in there, I know what d theta dt is. That's 2 pi over 9. So if I do this calculation here in Desmos, for example, or on your calculator, wherever, I end up with this answer here. There's some differences in the decimal points. My decimal point is 0.69. I didn't do any rounding along the way, but I think it would be very, very close to that answer there. So anyway, that is that, kids.